Okay, class. Alright, Assalamualaikum warahmatullahi wabarakatuh dan selamat dengar ya. Good afternoon. For this class, so let's finish Laplace topic first, and then next class kita akan discuss MTE. We will discuss MTE in the 1 hour class. So for this class, I would like to finish the Laplace transform, and then for chapter 4, I will upload the notes to you. Later you can download from the e-learning. So the notes is already finished, and I will upload by video. Let's see this one. Initial value problem solving linear ordinary differential equation. So in differential equation, one of the methods to solve is by using the linear equation. So by using linear equation, what you do is you find the integrating factor. If you remember, in chapter 1 we have one method to solve linear differential equation. So in order to solve linear differential equation, you find the mu by integrating exponent px. If you remember that, you multiply the mu x with each term in the differential equation. So by using Laplace transform, this is one method to solve the linear differential equation. So it is apparent from the general result that Laplace transformations of dn y over dtn depend on ys equal to Laplace of yt and the n minus 1 derivative of yt. So for Laplace transform, you can transform any function, whether you have the differential form y prime ataupun dy over dx, dy over dt, and their derivative. So you can transform y, you can transform y prime, y double prime, and so on. And then this make the Laplace transform ideally suited for solving linear initial value problem in which the differential equation has constant coefficient. So this property make Laplace transform is ideally suited. You can use the Laplace transform to solve the initial value problem. So in order to use Laplace transform, you must have the initial value problem. Initial value problem means you have y0, you have the value for y0. If you want to solve the linear differential equation but you don't know what is the initial value, then you cannot use Laplace transform. Also, if you have a second order differential equation, you must have two values for initial value. First is y0, second is y prime 0. So such a differential equation is simply a linear combination of term y, y prime, y double prime, and so on. So normally when you write the differential equation, actually it is a combination of function y and their respective derivative. So you have a combination of y plus y prime equal to 0, for example. That is a linear equation. And you also can rearrange, or you can write the linear differential equation in terms of this function. Given that we have the order of n, so you must have the n initial value. So you have from y0 to yn minus 1. All together is n. So by the linearity property of Laplace transform of this linear combination, so when we apply the Laplace transform for differential equation, each term in Laplace transform each term in differential equation, you can transform into Laplace form. So for example, let's say you have y plus 2y prime equal to 2. So this is a linear differential equation. By linear, I mean y is the dependent variable. We have y. We also have the derivative of y, which is y prime. So linear means the coefficient or the variable for dependent variable, the highest power is 1. So you cannot have y square, you cannot have sine y, cos y. That is not a linear. If you have y and the derivative is y prime or y double prime, then this is a linear differential equation. So if you have this form, then each term you can transform. So you can find the Laplace of this one, Laplace of this one, and also Laplace of function 2. You can transform all the terms in the differential equation. So the transformation of y in that equation is y. So we have y function. When we transform y, we get ys. Y prime, which is the derivative of y. So y prime, when we apply the Laplace transform, we will get a variable s multiply ys. Ys is the transformation of yt. So if you transform yt, you get ys. If you transform y double prime, y prime, you get s multiply ys minus y0. What is y0? It is the initial value problem. The value that given when this function y at 0, at x equal to 0 or t equal to 0. This is for y prime. What about y double prime? So when we transform a function y double prime, for example, we are solving second order. So of course we will have y double prime. So you transform y double prime, you get s squared multiply ys minus s multiply y0. Y0, once again, this is the initial value, and y prime 0. So this one also initial value given for the derivative of y, yt. So here we are using yt. This is y double prime. So if we follow through y to the power of n, hence this is the general form. So for this course, you need to use only 1, 2, 3 also, 3 only. So biasanya kita akan solve the equation up to second order only. So this 3 formula is going to be used to solve up to second order values. So how to solve the differential equation by using Laplace transform? So we start here. So we start at here. Now you have a differential equation, whether it is a first order, second order. So what you need to do is you identify what is yt, what is y prime t, or y double prime t. And you also must identify whether this is a linear or not linear. If not linear, then do not proceed lah. You cannot solve by using Laplace. If linear, also you can proceed using the Laplace transform. Right now, you identify what is yt, y prime t. You also know the value at y0, y prime 0. What you need to do is you apply the Laplace transformation. So you transform all the term in the differential equation by using the linearity properties of Laplace transform. So one differential equation you can separate by term by term. After you have transformed everything into Laplace transform, now what you need to do is, if you remember back, when we transform yt, we get ys. When we transform y prime t, we also have one term here, ys. Also same with y double prime, we also have ys. So after you transform everything, of course in the equation you will have ys and sys at some places. So what you need to do is, you need to express that expression in ys. So you solve for ys. You find what is ys. So by algebraically manipulating the equation, you find ys is equal to what function? That function actually is in the Laplace form, because you already transform all the equation into Laplace form in ys. So now you have ys equal to some function. That function actually is in the form of a rational function. Whenever you want to solve the differential equation, lastly your expression of ys will consist of one rational fraction that we just have learned last week. So now you have the rational fraction. So what you need to do for the rational fraction, you decompose it. You simplify the rational fraction into simple fraction. So you decompose it by using the method that we learned last week. After you have decomposed the rational fraction into simple fraction, now you apply inverse Laplace transform. So next step is, after you have simplified the rational fraction, you apply the inverse Laplace transform to solve for ys. Now from ys you get yt. So that yt is the solution. So after you have transformed everything, you solve for ys, now you inverse transform. Now you get back yt. So that yt is the solution. Clear? So first you have yt, you transform into ys, and then you solve for ys. Now you transform back by inverse Laplace transform, you get yt. That yt is the solution. For example, let's see example 9a. Find the solution for the following initial value problem. So this is the linear differential equation. So we have here the term dy over dt. Here we have the term minus 5y, and this is equal to 15. If we go back to chapter 1, actually we can solve this equation by applying the linear equation. So if you want to solve by linear equation, first you need to find the integrating factor, mu x. So integrating factor, so you integrating exponent negative 5x, then you multiply which is term, and then you simplify, you integrate back, you get the answer. Now we are going to apply Laplace transform. So dy over dt. So dy over dt, this is y prime lah, y prime. And this is minus 5y equal to 15. And when we want to solve by using Laplace, we must have the initial value, because this is first order only, dy over dt. So you must only have one initial value. If this is second order, you must have two. That is the rule. For first order only one. Second order you need two. Sama jugalah macam kamu nak solve simultaneous equation. If you have two variable x and y, you must have two equation. If you have three, you must have three equation. For example, you have x, y, z variable. So you want to find what is y, what is z, what is x, you must have 3 equations. Same with differential equation. First order, you must have 1 initial value. Second order, you must have y0 and y prime 0. So this is for first order. Alright, so we are going to solve this by using Laplace transform. So how did we want to start? First, we start with transform this linear differential equation into Laplace transform. So we apply a Laplace transform. So apply for right hand side and left hand side. So Laplace of dy over dt minus 5y equal to Laplace of 15. So we are going to transform all the terms. Now by using the linearity properties of Laplace transform, so the transformation of the left hand side, actually you can separate one by one. First, transformation dy over dt minus 5. You can put outside minus 5 and then you transform only y, and transformation of 50. So what is the transformation of dy dt? So by referring the formula, look back in the formula. So dy dt, this one, y prime is dy dt. So this is s ys minus y0. So s, small letter s, ys minus y0 minus 5. What is transformation of y? This is yt, so you get ys minus 5ys. And then transformation of 15, 15 over s. So now we have the initial value at y0. This is equal to 1, so you substitute into this one. So we have s ys minus 1 minus 5ys. So I put this one in bracket also, equal to 15 over s. So now we are going to solve for s. Kita nak selesaikan for ys. Sorry, solve for ys. First, we are going to transfer this one minus 1 to the right hand side, and then we are going to group sys and minus 5ys. So we have sys minus 5ys equal to 15 over s plus 1.
Bukan negative 5, jadi equal is not.
Pardon? Ya?
Salah.
Betul Okay.
Sorry lah.
Okay. Continue. So this one is 15 over s. So 15 over s. Firstly, we simplify dulu lah. So this one is 1 over 1. So we multiply by s, multiply by s. This is equal to 15 plus s over s. Plus s over s. Clear? Okay, so next On the right hand side here, left hand side, we have s ys minus 5ys. So why not we factorize ys? So we have ys in bracket s minus 5. Tadi clear sikit lah s dengan 5 tu kan. So here we have 15 plus s over s. And then what is ys? Ys is 15 plus s divided by s multiply s minus 5. Now you have a rational fraction. Ys is the solution. But now to inverse Laplace transform this one, this is a rational fraction. So you need to simplify this fraction. So 15 plus s over s minus 5. Actually this one you can break down into two simple fractions. One consists of s denominator, second one s minus 5. So for s, this is a linear, so you have a. For s minus 5, this is also linear, so you have b. So we are going to simplify for numerator. 15 plus s equal to a multiply s minus 5 plus b multiply s. I now solve for a and b. So I would like to solve for a first. That means let s equal to 0. So if s equal to 0, 15 plus 0 is 15 equal to a multiply s minus 0 is s. So as plus b times 0, 0. So a equal to 15 over s. Silap bukan 5 kan? Saya dah confuse lah s dengan 5. Sorry. Padam balik. S is 0, so 0 minus 5 minus 5. So what is a? Negative 3 ya. A equal to negative 3. Betul ke ni? Dah record video kan? Betul kan? Saya check balik. 15 plus s minus 5 plus bs. So s0 15 equal to minus 5a. A equal to 15 divided by minus 5 minus 3 kan? Okay, so solution tak apa. Tak apalah, kita sambung, kita teruskan ha? Okay, now solve for b. So macam mana nak solve for b? S equal to 5 So let S equal to 5 sama, so dia confused lah. Okay, when S equal to 5 for right hand side, 15 plus 5, 20. 5 minus 5, 0. So 20 equal to 5S kan? F and B confused lagi ya. So what is B? 4. Okay, B is 4. 20 divided by 5. 4 betul? Okay, so this one, so saya convert kat sini terus dah. So this one actually A is minus 3 over 5 plus 4 over S minus 5. So this is YS. minus 3 over s. Okay. Minus 3 over s. Okay. So how to get yt? To get yt, that means you need to inverse Laplace. So yt is equal to inverse of ys. That means inverse of minus 3 over s plus 4 over s minus 5. Tak nampak kan? Okay, so sambung lagi. Minus 3 you can put outside. Minus 3 you can put outside. So we have 1 over s. 4 also you can put outside. So you have 1 over s minus 5. So sambung kat tadi pula. So this answer yt equal to minus 3. Inverse of ys is 1. So minus 3 times 1 is equal to minus 3. Plus 4. 1 over s minus 5 is exponent 5t. So this is our solution. This is our answer. Alright, second example. Example 9b. Find the solution for the following initial value problem. So for this problem, we have a second order linear differential equation. So second order we have d square y over dt square minus dy over dt minus 12y equal to 4 exponent minus 2t. And to use the Laplace transform, you have two initial value. First for y0, second for y prime 0. Alright, so first we apply Laplace transform for each term. So Laplace of d squared y over dt squared minus dy over dt minus 12y equal to Laplace of 4 exponent minus 2t. Now you can use a linearity properties. You can separate one by one. So this is equal to Laplace of d square y over dt square minus Laplace of dy over dt minus 12 outside Laplace of y. This is equal to 4 outside Laplace of exponent minus 2t. So first one, Laplace of d square y over dt square. So by using the formula, referring the formula, this is s square ys minus s y0 minus y prime 0. So let's put this one in one bracket. This is for d square y over dt square. And then Laplace of dy over dt sys minus y0. Square bracket. This is 1. And second, minus 12. Laplace of y is ys. So this is equal to 4. Laplace of exponent minus 2t is 1 over s plus 2. Ataupun kita combine teruslah supaya kita tak confuse dah. So 4 over s plus 2. Alright, now we are going to substitute the initial value that we know. So what is the y0? When y equal to 0, we have 0. When y prime 0, we have 1. So here we have 1, here 0, here also 0. So substitute. So solve this one. We have s square ys minus sy0 is 0. So minus s multiply 0 minus 1. So here I open the bracket. So minus s ys. So minus minus plus y0 is 0 minus 12 ys equal to 4 over s plus 2. So you should be careful lah. Ini sometimes when you not be careful, you tend to make a mistake lah. So negative, negative, positive, tapi dah tambah 0, so doesn't change the value lah. Alright, so we have sy so here s multiply 0 is also 0. So here 0, 0. So now let's group the ys. So ys, first we have in bracket s square minus s minus 12. And then here we have 1, so transfer to the right hand side. So we have 4 over s plus 2 plus 1. Okay, so simplify this one first. This is 4 plus, so this is 1 over 1 kan? Multiply s plus 2 over s plus 2. So we have s plus 6 s plus 6 over s. So here we have ys s square minus s minus 12. Here we have s plus 6 over s plus 2. And then what is ys? S plus 6 divided by s plus 2 multiply s square minus s minus 12. So ys is our solution for this initial value problem, second order. And then in order to transform back this ys, so first we need to simplify this fraction. So this one, actually you can simplify into factorial form. So s minus 4s plus 3 again. So s plus 6 over s plus 2, and this one you can simplify into s minus 4 s plus 3. So now we have 3 fractions. So the first one we have s plus 2, second one s minus 4 s plus 3. So for s plus 2, this is a s minus 4, b s plus 3, c. So we have 3 variables. Alright, so you cross multiply. So macam mana kita nak simplify the numerator part? Okay, so you look at a. The denominator is s plus 2. So you multiply with s minus 4, s plus 3. So a you multiply with s minus 4 and s plus 3. For b, because you have s minus 4 already, so you just multiply with s plus 2, s plus 3. So s plus 2, s plus 3. And for c, you already have s plus 3, so you multiply with s plus 2, s minus 4. And all of these are equal to s plus 6. Alright, so we are going to solve one by one. So observe each of our coefficient. So we have a, s plus 4, s plus 3, b we have s plus 2, s plus 3, c we have s plus 2, s plus. So to solve for a, so let's see, if we want to make b goes to 0, c goes to 0, why not we set this one as equal to 2? Minus 2, If I put minus 2 here, this one minus 2 plus 2, this one 0, so everything 0. Here also 0. So let s equal to minus 2. So minus 2 plus 6, 4. A multiply minus 2 minus 6. Minus 2 minus 4 is minus 6. Minus 2 plus 3. 1 multiply minus 6, minus 6. B and C is 0, kan? This one minus 2, 0. Minus 2 also 0. So here this one is, let me do calculation here. So minus 2, so here will be minus 6. Minus 2 plus 3, 1. So minus 6 times 1, minus 6. Okay. So what is A? A equal to 4 divided by minus 6, negative 2 over 3. A is minus 2 over 3. Now solve for B. Okay, kita tengok balik B, Kita nak solve for B, that means A must be 0, C also must be 0. So how to make both A and C goes to 0? Apa yang common dia? Yes. So let S equal to 4. Let S equal to 4. 4 plus 6, 10. A will be 0. C also 0. So B equal to 4 plus 2 is 6. Multiply 4 plus 3, 7. So B 7 times 6, 42. So B equal to 10 over 42. Over 21. And to solve for C, that means A and B must go to 0. That means we set S equal to minus 3. So let S equal to minus 3. So minus 3 plus 6 is 3. A0, B0, C minus 3 plus 2 is minus 1, minus 3 minus 4, minus 7. So C equal to 3 divided by 7. Okay, so we write back A. So YS equal to A minus 2 over 3 over S plus 2 plus B 5 over 21 over S minus 4 plus C 3 over 7 over S plus 3. So this is a simplest fraction in YS. So not finished yet because we don't want YS. Kita nak YT. So how to get YT? Inverse. So find the inverse Laplace. So I write here YT equal to inverse Laplace of everything here. So let me make this one. So this is by using the linearity minus 2 over 3 we can put outside. So we have 1 over S plus 2. 5 over 21 put outside. We have 1 over S minus 4. And then 3 over 7. So saya sama ke bawah plus 3 over 7 1 over S plus 3. So we have minus 2 over 3. S plus 2 is exponent minus 2t. Five over 21 exponent 40. and 3 over 7 exponent minus 3t. So this is the answer. So di second order, kalau kamu tak guna method Laplace, you need to transform intercharacteristic equation. So you need to transform m square plus blah 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 and then solve for m, solving the quadratic equation, solve for m. After that, solve for non-homogeneous part pula. Tadi kita ada exponent, so you need to find yp prime, yp double prime, so panjang. Actually by using Laplace, it is more simple. Okay, last, dah habis ni? Belum, okay, saya tunggu. Nanti lepas kelas saya bagi link attendance. Sekarang nak guna handphone pun tak boleh. Saya lupa lah nak bagi attendance. Dah tengah record, so nantilah lepas kelas saya bagi. Okay, example C, 9C, find a solution for the following initial value problem. So we have second order, so we need to have two initial value. So apply the inverse Laplace, apply Laplace transform. So d square y over dt square plus 4y equal to Laplace of exponent minus 2t. So for second order, so d square y over dt square plus 4y plus exponent minus 2t. So for d square y over dt square, this is s square ys minus sy0 minus y prime 0. That is for d square y over dt square. For y you get 4ys and exponent negative 2t is 1 over s plus 2. Substitute the initial value, so y0 is 2, y prime 0 is 1. So s square ys minus s y0 is 2, so 2s minus y prime 0, so minus 1 plus 4ys equal to 1 over s plus 2. So simplify for ys, So ys equal to s square plus 4. So saya potong yang ada ys. So s square plus 4. And then minus 2s plus 1 we transfer to right hand side. So this is equal to 1 over s plus 2 plus 1 plus 2s. Alright, so simplify this one. Simplify this one. So macam mana nak simplify? Tak boleh berusaha juga. Next sedikit. Copy. Dia aku dulu ys s square plus 4. Okay. So yang ni 1 over 1, yang ni 2s over 1. So you multiply with s plus 2 over s plus 2. Kita buat ini sahaja. So 1 over 1, so multiply s plus 2 over s plus 2. And then tadi plus 2s kan. So 2s over 1, so you multiply s plus 2 over s plus 2 juga. So now everything is over s plus 2. So you have 1 plus s plus 2 plus 2s squared plus 2s. Mana? 2s squared plus 4s. Okay. So 2s squared plus 5s plus 3 over s plus 2. And then here ys. So kita bawa ke sini, jadi s squared plus 4. S squared plus 4 ni dah tak boleh nak simplify kan. So we have 2s squared plus 5s plus 3 over s plus 2 over s squared plus 4. Alright, now we want to simplify this fraction. So 2s squared plus 5s plus 3 over s plus 2 over s squared plus 4. This is equal to first s plus 2, second s squared plus 4. S squared plus 4 cannot be reduced lagi ya, dah tak boleh nak reduce balik lah. If this one can be reduced, you reduce lah itu the factorial form. Now dah tak boleh nak factor, so kita tinggal. So first one is a, because bawah dia s eh? Second one is bs plus c. So a multiply s squared plus 4 plus bs plus c multiply s plus 2. square plus 5s plus 3 equal to a s square plus 4 plus bs plus c multiply bs plus s plus 2. 2s square plus 5s plus 3 equal to a s square plus 4 plus bs plus 2. Okay, right. Now we want to solve for a, b and c. This one we cannot simply solve macam example yang tadi lah. So we just choose whatever value s yang give us the smallest value lah for this one. First one we can solve for a by letting s equal to minus 2. So if we put s equal to minus 2, then b and c will equal to 0. Okay, so 2 multiply minus 2 square plus 5 multiply minus 2 plus 3. So here minus 15. A minus 2 square 4 plus 4 8. So A equal to minus 15 over 8. Sorry, ini 1 kan? Sorry, this is 1 This is 1, so A is 1 over 8. Kamu semua percaya saya? Betul kan? 11 2 times 2 4 4 minus 10 plus 3. Oh, betul. Betul kan? 4 minus 10 8 11 minus 10. Okay, A is 1 over 8. Now let's choose the simplest equation. Let s equal to 0. Let s equal to 0. So 0 0, so here will be 3. A is 1 over 8. 1 over 8 multiply 4. 2 over 8, 1 over 4. When s equal to 0, b 0. So plus 0 here c times 2. So what is c? 3 minus 1 over 4. 5/4. 1/2 salah. Betul itu pun salah. Okay, now let S equal to 1. So we have 2 plus 5 plus 3. 7 plus 3 is 10. 1/8. 1 plus 4 is 5 plus B, C is 5/4. 1 plus 2 is 3. Okay, so for B, (15/8). Betul tak?
Betul.
Check tak tu? Check, okay. So A 1/8, B 15/8, C 5/4. So YS is 1/8. 1/8 over S plus 2 plus 15/8S plus 5/4 over S squared plus 4. So this is our YS. Then to get the YT inverse, S plus 2. So I skip terus saya dah hasilkan siap-siap kan. (15/8S). Sini kita boleh hasilkan siap-siap. So S square plus 4 into 2 fraction. So 5/4 over S square plus 4. This one you can separate into these two things. Okay, so now we have a constant. You can put the constant outside. So 1/8 put outside. So we have 1 over S plus 2. 15/8 also you can put outside. So you have S over S square plus 2 square. 4 is 2 square. So 5/4 also can put outside. So here is 1 S square plus 2 square. So 2 square. So atas ni kena darab 2. Sini kena bagi lagi 2. So the first one we have 1/8. 1 over S plus 2 is exponent minus 2t plus 15/8. This one is cos 2t for x equal plus 5/4 divided by 2, 5/8. This one is sin 2t. Alright, so that is our answer. Okey, siapa yang tak faham? Baik, semua faham ha? Okey, so kalau semua faham, so kita buat satu exercise lah. Kita buat satu sahaja lah. Yang lain kamu try balik buat kat rumah lah. So buat A saja. Try to solve exercise 9 number 1. So ada A, B, C, D, E, F. So just do A only. B, C, D, E, F ada jawapan. Nanti kamu balik kamu try Try ni waktu nak exam lah. Sekarang tak try tak apa. Boleh? Okay, A simplest equation
Yang lain pula.
Okay, so saya dah tengok ada yang buat B dah buat C ya. So yang A ni saya assume okay ya. A sama dengan apa tadi? A negatif 1, B 1 kan. Okay, so when you solve the fraction you get A negative 1, B equal to 1 and then you inverse balik lah. So dapat balik ya jawapan dia. So I think tak perlu bagi lah. So answer dah ada lah, -1 plus exponent T. Alright, so I think that's all for today. For Thursday nanti kita tak masuk tajuk baru lagi, tapi kita akan discuss midterm dulu lah. Okay, with that, thank you. Assalamualaikum warahmatullahi wabarakatuh.